And what is up, space weather enthusiasts? We're bringing you another daily space weather show here at the Smash News Network, least busted name of news. We're looking at the past 24 hours on the closest star here. That's 171 angstroms from Solar Dynamics Observatory. And as expected, the most active region has been in the eastern hemisphere. It was that southeastern sunspot that did produce an M-class flare. We'll get to it. Also, a new sunspot rose there below our Earth scale. So we've seen a decline in solar activity in the past 24 hours, despite that new sunspot rising. Let's take a little closer look here. These are 24-hour videos from SDO. And we'll zoom in one additional step here. There are huge plasma filaments on the Earth-facing portion of the solar disk. There were some rather spectacular coronal mass ejections that have occurred in the past 24 hours as well. We'll cover those in the detail that you may have come to expect from the channel. Here's our northern hemisphere. We're going to switch to 304 angstroms here after this plays through because there was a coronal mass ejection that was captured on yesterday's video. We picked it up on the GO 16 SUVI. Here's 304 angstroms, and you'll see up there in the northeast, you'll see, actually I believe that was a filamentary collapse, not a coronal mass ejection. So that filament certainly looked like it was going to head out, but instead it splashed back down over there on the far side of the sun. Here's a little closer view of that. Again, there are still massive plasma filaments suspended on the Earth-facing portion of the solar disk. So we've really been seeing a shortage of coronal mass ejections, solar flares, etc. for the past week or so. So surprisingly low levels of activity here. However, keep in mind we are still about a year out from solar maximum. So we've got a long way to go as far as the solar ramp-up is concerned. So before we move on to look at sunspots here for a brief moment, here's a 24-hour video of the equatorial region, the ever-popular picturesque lower corona featuring quiet corona, 171 angstroms. Ionized iron, the house favorite wavelength. So here is August 24th and August 25th to date, the SDO continuum there. And again, a new sunspot did rise right down here. Not as big as the ones that are ahead of it, and I don't see any magnetic complexity yet. However, it is a little bit early to tell, as it has just peeked over that southeastern solar limb. Let's briefly take a look at what's going on planet Earth. There has been some eruptive activity for sure. Here's a great view of Santiaguito, located in Guatemala, as it's been producing some explosive activity, some paroxysms. Fantastic view there of the Guatemalan volcano, Santiaguito. Let's see what else is going off. Kilauea now back on the list. First, Suminose Jima producing a 6,000-foot ash plume. Kilauea, elevated seismic unrest, also ground deformation happening there. It looks like Kilauea is going to go off again, so expect further eruptions on the Big Islands. Recently quite active volcano Kilauea. Especially the southern slope, there's some significant deformation happening there. Shishaldin in the Aleutian Islands, basically what they're saying there is we don't know if it's going to go off. It could be calming down. It could be about to explode more. So Shishaldin there, unsure of its forecast. Santiaguito there, extrusive and explosive eruptions. Some degassing of gas and water vapor there over Guatemala. It's producing about a 15,000-foot plume of volcanic ash. Please do not pole vault the caldera. Also, Nevado del Ruiz exploding. In Colombia, no indication on the ash plume there. Sabancaya in Peru exploding, flight level 210. It's a 21,000-foot ash plume. As Sabancaya explodes. Next, the past 90 days of earthquake activity, and we are seeing a bit of a 7-magnitude earthquake shortage here. So we are overdue for a 7-magnitude earthquake. Let's see what's been going on in the past 24 hours. We'll call out quakes above a 5 magnitude. Although there is one off the coast of Oregon, which we will also cite here. So these are the quakes of 5 or greater magnitude, starting with a 5.0 at Vanuatu. It was at 20:08 Universal Time yesterday evening. There it is, east of Australia. Continuing up the list, the largest quake of the past 24 was a 5.8 at Japan. It was at 22:48 Universal Time. There it is near the eastern coast of Japan, 5.8 at 22:48 Universal Time. Then, about a half an hour later, a 4.5 off the coast of Oregon. So keep in mind, folks, any earthquake can be a foreshock. So just be aware of that. And that is where the earthquake coverage ends and the space weather coverage continues. So before we look at some stats here, let's take a look at the closest star zoomed in on the equator there in 304 angstroms. Just a spectacular wavelength here. It's great at showing active regions, filaments. It's ionized helium from the Solar Dynamics Observatory. It's also pretty good at showing flares, and the largest flare of the past 24 hours did come from this sunspot down here in the southeast. The 10.7 centimeter radial flux now all the way down to 141 solar flux unit, 144 solar flux units. So the 10.7 here dipped once again. Again, an overall decline in solar activity. Don't expect that to continue. Again, we are like a year out from solar maximum, so it is a long way to go to solar maximum based on all of the data that we see to accurately forecast solar cycle 25. There's the 1-year graph of the radial flux depicted by the black line. The red line depicts the sunspot number. See how proportional they are. And here's a space weather enthusiast dashboard. NOAA not forecasting any geomagnetic storms or geomagnetic unrest, and I would tend to agree, so let's move on to take a look at Earth's magnetic moment from space. This geospace magnetosphere movie depicts the last 4 hours of magnetohydrodynamic pressure as modeled by the space weather modeling framework. Magnetohydrodynamic pressure is measured in units called nanopascals. Again, it is geomagnetically calm on planet Earth. Here's Earth's magnetic moment from the ground depicting magnetic flux density. This is measured in nanotesla. It is the last 4 hours. And things are calm, and if there is a pole flip coming, where's the quadrupole, hexapole, octapole? We don't see it. One of the many reasons why we don't believe there is a pole flip in our near future. Next, the planetary K-index. Again, geomagnetically calm conditions. KP1 is the current situation. The planetary K-index, for all you new viewers out there, and thanks for tuning in, the planetary K-index is an average of global geomagnetism. Now, we were having some issues with the real-time solar wind, so we're going to just show the ACE spacecraft's data here. There is ACE, and you can see the real-time solar wind here. Actually, that's not really the real-time solar wind, but that was last updated at 10:02, so it's pretty up-to-date there. Solar wind speed here, just over 400 kilometers a second. Solar wind density here, something like 1.5 to 2 protons per cubic centimeter. It is nominal and pretty uneventful as far as solar wind goes. Here are our GOES magnetometers. And we are approaching a sector boundary crossing, which we will show you here next. The GOES magnetometers, they measure Earth's magnetic fields from the geosynchronous orbits of the GOES 16 and GOES 18. They're located at about 23,000 miles of altitude. They're way up there toward the outer portion of the outer Van Allen belts. So here is our top view ecliptic plane field plot, and Earth is just about to snap into a North Pole current sheet. It's pretty decent sized over here. There's the North Pole current sheet depicted in blue and green. Here is the South Pole current sheet that Earth is just about to snap out of. We'll let that play through one more time. That depicts 4 days, by the way. We show it daily on the channel. It's one of the best predictive values of any space weather information that we show. So there's the final image. Again, a couple hours here and Earth will snap into a North Pole current sheet, which should persist for a few days, assuming nothing changes, and sometimes it does with basically no warning. Here's our line of sight field plot. And yeah, there's the sun's B field depicted in blue. This is the torus that people are constantly talking about. And as we ramp up to solar maximum, you see that thing getting quite chaotic looking. Polar fields here depicted in green for north and red for south. And then, of course, you've got the gong magnetogram in grayscale. And let's move to coronal holes. So coronal holes, in my opinion, are a super important part of the solar cycle. Did you know that at solar minimum, the coronal holes are just attenuated at the poles for extended periods of time? Yeah, the coronal holes, they just kind of hang out at the north and south polar regions there for like a year at a time around solar minimum. And then, as the solar cycle progresses, those coronal holes migrate to the opposite poles, which is what we're seeing now. And we do have mostly North Pole coronal holes here. Let's take a look at those from SDO. There's the last image. So the only South Pole coronal holes are up here in the northwestern hemisphere. And here's the best wavelength from SDO, 211 angstroms. So basically, these are south. Not very well defined there, as there is a lot of bumpy plasma in between us and them. The rest of these are all North Pole oriented coronal holes. There are some down here as well, again obscured by plasma. And the sector boundary crossing is something like this. So there you go, that's 211 angstroms, one of the many species of ionized iron from the Solar Dynamics Observatory. It's depicting 24 hours, as is one of the conveniences of doing daily space weather. We put together 24-hour videos for people just like you. Next, we'll talk sunspots. We do have a continued likelihood of large solar flares in one location, the eastern hemisphere. So, namely sunspot 3413 is the most likely player to produce a large flare, but 3415 has been the M-class producing sunspot of the past 24 hours. Let's take a look at sunspots here from SDO's perspective. Again, we've got a significant likelihood here of large flares. The flare monitor here showing the likelihood of M-class flares over on the western limb also. So that's something else to keep an eye on. Now, when I say eye on, well, pardon the pun. So here's the past 24 hours in SDO continuum. I still suspect that this sunspot is the most likely to produce large flares moving forward. This one here's also got a chance, and this one over here. As it approaches the limb, the likelihood does go up. So 3 places that we could see an M-class or larger flare. And next we'll go to energetic particles and flares. All right, so the GOES proton flux here has not seen any spikes, so we did see that M-class flare. It did not fire any relativistic particles at Earth. The GOES 16's proton flux there remains flatlined. Don't expect that to continue. Expect more and more solar energetic particle events as we ramp up to solar maximum, which we, by the way, are not at yet. So there's the largest flare of the past 24. Peak flux was around 110 this morning, and it was an M1.4 or so class solar flare. Again, solar activity declining in general here. The background X-ray flux here making it all the way down to a B6 range. So again, a decline in solar activity really over the past the past week or two here. So significant decline there. And let's move to our flare wavelength. Here we're showing 94 angstroms. And again, that M-class flare came from down here. So right there was that M-class flare. We'll let that play through. Again, peak flux was just after 1 o'clock this morning on August 25th. Next, we suspect a lot of people will be looking up at the sky because of the super blue moon, the super blue new moon, the super blue full moon, which is coming on, is it August 31st? I don't know. We've got an article about it. Here is the third brightest object rising ahead of the sun there, Venus, making its way up as Saturn sets in the west. So that's what's going on, and let's take a brief look at cosmology. We need humans to classify galaxies. Yeah, so Galaxy Zoo is the Zooniverse project, zooniverse.org, that I have done the most work on here, classifying hundreds of galaxies. AI is incapable of doing this like so many other things, so we need humans to do it. So check it out. This is, let's see, that's definitely features, not a smooth galaxy at all. You only classify the central galaxy here. You ignore the other items. So it's not an edge-on disk, certainly not. It does not have a bar. It does not have a spiral arm pattern. It does not have a bulge. I'm going to say no bulge. Are there any bright clumps? Yeah, I'd say there are some bright clumps. I would say that it is a major disturbance, maybe even merging. It looks almost like the merging image. Let's say that's merging. So likely two galaxies there at a great distance, it looks like. And what do we see? Irregular shape, possible dust lane, possible overlap, central diffraction spikes, and there you go. Galaxy classified there at Galaxy Zoo, part of zooniverse.org, the world's largest citizen science project. So let's do a solar system forecast next. This is where things are today. And there you go. There's where things will be in 1 week on September 1st. And where has the summer gone? We're approaching the September equinox. Let's talk about the super blue moon. So the reason it is a supermoon is because of the apogee and perigee. The moon appears about 14% brighter when it is at its closest location, the perigee. It's about the difference between the size of a nickel and the size of a quarter. So you may not notice the difference, but it will be brighter if you've got clear skies. So a great time to photograph the moon as well if you've got the appropriate technology. This article from scitechdaily.com. And let's talk about Neptune. So of course the discovery of Neptune was first made mathematically. So it has to do with the orbits of Uranus and so on. And of course we've only been viewing Neptune for a short period of time, less than one orbit of the outermost planet. And the existence of Neptune was theorized before it was viewed directly because of the perturbations of other orbits, folks. So this is why it is not necessarily very significant to find dark spots, as gas giants are stormy places. They have very turbulent atmospheres. So anyway, mysterious dark spots detected on Neptune. It will have people in a tizzy. So of course, again, we haven't had a lot of time to observe Neptune in great detail. Those dark spots show up the best in the blue wavelengths. And do I have any idea what's going on Neptune's weather? Well, the answer is absolutely not. However, there are some basic physics that are going to control the weather every place. So it's something like a low pressure zone, I would suspect. It's probably something like high cloud tops. And if you want to read more about that, discovery by the Muse at ESO's VLT, Very Large Telescope. Once again, check it out at scitechdaily.com. Mysterious dark spot on Neptune detected from Earth for the first time. Oh, noes. Neptune's weather. Are you spooked of... Please don't be spooked of Neptune's weather. It's just ridiculous. This thing takes like 160 years to orbit the sun. And let's move on to apod.nasa.gov. So the astronomy picture of the day is Saturn. And of course, Saturn gets much brighter when its rings are at a certain angle. You can see the hexagonal solar, the north polar vortex there showing up very good in some of this imagery. By the way, this is shot in the Blue Mountains of Australia by Andy Casely. apod.nasa.gov. And of course, when Saturn is in this sort of a state, it is not as bright as when it is in this sort of a state because the rings are very large and very reflective. Some great imagery there of Saturn. Let's move on to CMEs. And those are yesterday's images. There is a great spectacular CME right at the end of the day yesterday. So late in the day, a coronal mass ejection there popping off in the northwestern limb. Doesn't appear to have any earthly directed components. Here is LASCO C2 and C3. Just a stellar light show going on out there in the coronagraphs. We'll also show stereo A, and we've actually paused this here to show that CME. Again, happening late last night and into early this morning. That coronal mass ejection off to the northwest, not earthly directed. And let's bring these up to the latest images here and manually move them because it's showing a lot of data. So there is that northwestern coronal mass ejection. Quite a dense core there. And since then, just some mild outflows. So the sun underperforming here in terms of CMEs, in terms of solar flaring activity, and indeed in terms of sunspots and radio flux. So let's show our 24-hour videos here. Now we've got the SOHO LASCO C2 and C3 all together. There you go. Here's a little closer zoom. Here's an even closer zoom. In the middle, that's SDO, 193 angstroms. And here's that wavelength all by itself. And let's talk about filaments. So there is certainly one major filament, this one in between these two sunspots. That one is clumpy. It looks like it might be getting a little bit less stable here. So that is one of the more likely places to see a CME come from. However, there are additional filaments all over the Earth-facing portion of the solar disk. That data from Lermonth, Australia's ground-based National Solar Observatory Hydrogen Alpha Telescope. It's showing 6,562.8 angstroms. That is the extreme ultraviolet emissions. Actually, that's just, let's see, that's just ultraviolet emissions from the hydrogen. So filaments show here as dark absorption features. They're blocking some of that hydrogen emission. And here is our grayscale image. Some large prominences continuing here on the eastern limb. And let's show filaments. Here we've placed together the SDO 193 plus 304 angstroms wavelengths. We put the Earth scale just ahead of that huge clumpy filament there in between those two sunspots. It's easy to follow because of its proximity to those sunspot groups. And a great view of those prominences around the eastern limb there as well. Here's an even closer view of that huge filament. It's a little larger than planet Earth. And there's the full disk view for the past 24 hours. By the way, if you want to follow us on social media, the best place to do it is over on Twitter. The platform that some people refer to as X, which is not a brand. So I keep calling it Twitter. I'm just going to keep calling it Twitter. I don't care if they rebrand it Your Mama. I'm still going to call it Twitter. Actually, Your Mama would be a brand, but X is not. So I'm just going to keep calling it Twitter. Join us over there. It's my most active location on social media. And here are the past couple of hours from the GOES 16 SUVi. Crown prominence happening up there at the North Polar region as well as at the South Polar region. Expect those to continue in the coming years as we ramp up to solar maximum. And this brings us to bonus features. First bonus feature is charging hazards. We don't have any satellite charging hazards. There are no high-energy electrons building up inside of spacecraft or low-energy electrons building up on the outside of spacecraft. It's smooth sailing. The GOES electron flux here is at a little bit lower levels than we've seen. A little bit of a dip there in the GOES electron flux. That's measured using radiography from the geosynchronous orbits of the GOES 16 and the GOES 18. It's measured at the F layer of the ionosphere. Here's a one-year graph to put all of that in context, just in a sort of a low to moderate range here for the electron flux. And there's the forecast model. NOAA expecting a minor uptick in the coming days. Again, that's measured at the F layer of the ionosphere, so we'll show the vibrational frequency of that layer, the bridge between Earth and space. There it is. The previous day there depicted in vibrational frequency megahertz, which are millions of vibrations per second. Our channel shows this daily, as there are many pole flip enthusiasts who watch the channel who can't explain why there are no quadrupoles, octopoles, hexapoles, or other oddities showing up that would show up in the ionosphere data if there were an actual pole flip occurring. Here's the anomaly from megahertz. Anomaly in megahertz from the 30-day median. It depicts high-frequency anomalies in blue and low-frequency anomalies in red. And there are some anomalies there, mostly of the high-frequency type. Here's the latest image. That's 10:15 universal time for the ionogram and 10:15 universal time for the anomalygram. We also show total electron content. Total electron content is literally the free electrons from about 12,500 miles of altitude, the location of a GPS satellite, down to your handset. Those free electrons cause signal refraction, and that is the basis for GPS errors. We are seeing some significant GPS errors here, especially around Antarctica, the South Polar region. Some electrons there a little bit out of place. Not enough out of place to convince me that Earth's poles are flipping, though. This is a common thing that we see with lower levels of electron flux, so the data looks totally normal to me. If the total electron content freaks you out, it shouldn't. It's not scary in the slightest, but it does show you where GPS errors are most likely. Next, the total electron content anomaly from the 10-day average over North America. We are seeing significant high electron count anomalies here over locations such as Mexico, the Western Atlantic, Central America, the west coast of North America in general. Some there over places like San Diego, and stretching quite high up the west coast there. So some high electron content anomalies. There's the most significant one on the west coast of Mexico. Significant signal there for high electron contents. We'll play that through one more time. Then we'll show the largest and latest images of the closest star, since, again, we have a new sunspot that just rose over the southeastern limb. So there's the latest refreshes. There's that new sunspot. So far, it looks like it's only alpha class. I only see one umbra. This group up here is Beta Gamma Delta class. Barely. Actually, I think that's just Beta Gamma class. I see 4 significant ombre there. It's not that bad of an ombre. Those ombre. Those ombre are not that bad of that ombre. You get the idea. So this is still my favorite sunspot to produce a large flare. It is Beta Gamma Delta class. A little bit more magnetic shear there with that sunspot. So it does harbor the kind of magnetic fields we would expect to see associated with a large flare. And of course the flare monitor says this is a significant flare player. Also, I would agree mainly just because of its proximity to the limb, though. The magnetic fields there, that's just Beta Gamma class. Not so much Beta Gamma Delta class. And here's a full disc rock back for you. And it's time to get to meteorology. First thing we're starting out with is Saharan dust. Yeah, Saharan dust. It has a tendency to tamp down systems and prevent convection of major tropical storms. However, it looks like it's leaving this system alone now. So all this Saharan dust over here, it's mainly to the east of that system there, the one that's just north of the Isle of Hispaniola. So that's going to have some. It's going to build up a little bit. So that's the situation there. Not so much harassment by Saharan dust, although there is some wind shear to its north. So I think it's going to stall after it moves north a bit. It does not look like it's about to make landfall at the U.S. or anything like that yet. Its latest moves are basically just to the north. So anyway, let's take a look at wind patterns here. This is the surface wind scenario for the eastern world. We've got a strong low there north of the Philippines, and another strong irregularly shaped low here in between Hawaii and whatever those islands are. I have no idea. Too many islands peppering the Pacific Ocean. Here are the jet streams of this side of the planet, and it's blowing backwards over the northern Indian Ocean there. Here are the jet streams of the central world. There you can see that backward jet stream flow over North Africa, southern India, Saudi Arabia, and the Indian Ocean. Here are the surface winds of this side of the planet. Strong low there south of South Africa. The most hilarious of all BRICS nations, South Africa. If you're wondering what it stands for Brazil, Russia, India, China, and South Africa. Oh no, the economic powerhouse is going to shut down the U.S. They're going to overpower the U.S. with their economic powers of Brazil, Russia, India, China, and South Africa. Anyway, there you can see that low. And let's show the jet streams. The jet streams still here staying mostly north of the U.S. Anticyclone here looks like it's finally breaking down over the central U.S. Now let's take a look at pressure. We're going to show a forecast here. And since this low is now coming into play, let's check the pressure of it first. That's the mean sea level pressure. And it's not really that low of a low, only 995 hectopascals there. Not very low at the moment. And let's advance this 1 day. So we'll follow this one. There's the advancement in 1 day. It's according to the Euro forecast, it's going to move to the northeast. The GFS forecast shows it farther to the west, but also weaker. So not really a big deal there as far as that system goes. Here's your full Earth map. Mean sea level pressure, the world's lowest pressure, down here in the stormy Southern Ocean, west of the Drake Passage. Next, clouds and fog over the Americas. We use shortwave radiation because it's dark over most of this map as the sun rises over eastern Brazil. There's the situation from your satellite shortwave radiation station. We had some heavy rains here in Pennsylvania. They've moved through promptly. I think it has now ceased. Next, your smoke map forecast. This is firesmoke.ca if you want to go access it yourself. quite smoky in the northern U.S., especially the Pacific Northwest, and quite a few fires in the southeastern U.S. So that's your smoke forecast. And let's move on to our weather.gov map. Some flooding in the forecast here for Wyoming, Colorado, Nebraska, Kansas, and New Mexico. Hot temperatures forecasted for the southeastern U.S., or I guess you could say south central U.S., including the Gulf states. That heat is centered around places like Arkansas. Weather.gov, if your location is lit, click your location. And here come some forecasts. First, it is the GFS 72-hour pressure and precipitation forecast. So that's a 3-day forecast. So the GFS model does have that low shifting to the northwest. So the jet stream is still staying far north, and that is certainly affecting things. So that's your pressure and precipitation forecast based on the GFS model for the next 72 hours. Next, we'll show the GFS temperature anomaly forecast in degrees Celsius. And some cold pockets here mixing in the coming 3 days. Lots of Colorado and Wyoming will see anomalously cold temperatures. And there will be finally some respite for that heat in the central U.S. Again, at the 72-hour GFS temperature anomaly forecast in Celsius degrees. And here is your jet stream forecast. The 250 millibar winds. The jet stream remaining either incoherent or north of the U.S. here for the coming 3 days. That's going to allow weather systems to not really move so much from west to east. There you have it. That is your jet stream forecast. Next, your lightning mapper. We did see a little bit of thunder and lightning here in Lehigh Valley, Pennsylvania, which, by the way, is located right about here. We're like 18 miles from the New Jersey-Pennsylvania border. That's the last about 10 hours of lightning, and let's see if we have any terrestrial strikes as we produce the video. Looks like West Virginia's getting peppered a little bit. Dag, that is a severe thunderstorm. Those are some high lightning counts. So around Charleston, West Virginia there. A strong cell, which could be accompanied by damaging winds and hail. Next time you hear thunder, why the hell don't you look at lightningmaps.org? And why don't you look at smashomash.com? Did you know we built a massive web ring to benefit people like you? Back in 2019, we responded to the pathetic censorship of a certain big tech social media organization. Since we realized that social media is about as social as chaining yourself to the wall in your own basement with nothing but canned peas and vodka, smashomash.com was launched. We created a huge web ring, Smasho Forum, the Smasho merch, the Smash Team site for additional content. We're still on Patreon. We're all over social media. Hit us up over there. Press the share button. Press the like button. Check out the Amazon shop, which you can also link right there from the homepage. It's amazon.com/shop/smashomash, and buy your spices in bulk through our Amazon shop. We know everybody's trying to save money because of the pathetic state of affairs of the economy in the U.S. right now, as it's being shattered by, shall we say, terrible decision-making. We'll just say that. We make a bad curry at this place, and not bad meaning bad, but bad meaning good, to quote Run DMC. So pick up your spices in bulk through our Amazon shop and save a bunch of cash. Don't be buying curry in a little tiny jar that costs you $8. Buy it in a huge container like this one. That is, I don't know what the size is, but you save a bunch of cash buying your spices in bulk, folks. So get them through Amazon, get them through our shop. Help us out that way. Increase the probability these videos will continue to exist. Today's featured product is Do Not Pole Vault the Caldera. Now, I'm actually wearing this one myself. And, of course, I'm full of space because my shirt is green. So if you're going through hell, keep going. Do not pole vault the caldera. If you're going on a volcanic vacation, leave the vault pole at home. Keep your field events away from volcanic calderae. Don't pole vault the caldera. Don't try to be like Steve Stimpak. It's a terrible idea. This public service message brought to you at massive personal risk and expense by Smash staff and I, so give her a raise by picking up some merch and help get the ideas on the channel out there. SmashOmash.com. Listed on the shirt. Also, YouTube.com/SmashOmash, the URL of this very channel. And by the way, thanks for tuning in. Also, many other great merch items there. The Do Not Pole Vault the Caldera is the top seller. So that's some bandwagon advertising. And thanks to everybody who's picked up merch and helped to keep the channel in existence. There's also a Hemp Lucid shop that you can visit. There is a link below this video as well as on the homepage at SmashOmash.com. Today's featured product is the Stress Mushroom Gummies. This is in watermelon. And by the way, these are not going to make you feel drowsy. At least they don't make me feel drowsy. So that's my personal account, the Stress Mushroom Gummies there, available at our Hemp Lucid shop, as well as many other items. The CBD body balms are now back in stock, so check that out. And the best feature is SmashOmash.com/SmashTeam. If you want additional content, join us over there at the Smash Team site. We replaced Patreon with a superior site, our own. SmashOmash.com/SmashTeam. We send out email alerts for videos just like this one. So sign up at the bronze level. It'll cost you $0 per month, or support the channel at the silver level for $2.99 a month, or the gold level for $9.99 a month. The best value is the gold annual paid-up subscription. It's almost like getting 4 months for free, as it includes complimentary merch. Press like and subscribe if you are new to the channel. If you are old to the channel, thanks for sticking with us. We only produce the world's most comprehensive daily space weather content, as well as the most detailed imagery of the sun. We're approaching 4,000 subscribers, as if that's some sort of a milestone. We'll celebrate when we get to 5,000. Thanks to each and every one of you for tuning into the content. There is a revolution coming in the realm of science. I'll just leave it at that. And let's get to our final segment here. Oh, check it out. Some changes to the National Weather Service, the radar.weather.gov site. Pretty sweet. Not exactly sure what it is. I think that's the speed or something. Maybe that's the length of the forecast. Number of frames? I don't know. I'm not going to mess with it because I'm showing this series of storms that are moving out into the Atlantic. So check it out. Those storms by Charleston are pretty rough. Dag. Remember, folks, the most dangerous part of a thunderstorm in the northern hemisphere is the northwest corner. That's where tornadoes tend to form, and those are the kind of storms that would produce things like damaging wind and hail, possibly even tornadic activity. So let's zoom out and show the full 50 states view here before we focus on the lower 48 view here. And there is the full 50 state view, some heavy precipitation there in southern Alaska. Oh, we've got more levels of zoom now. That's pretty sweet. All right, so there's a lower 48. Here is clouds and fog. It's shortwave radiation from the NASA GOES Interactive Weather Satellite Suite. And there is your water vapor map. So there is a lot of dry, massive air up in this area. This is effectively a high pressure zone in comparison to this low pressure zone, which isn't really that low. So it's not looking too exciting for all of you hurricane hopefuls. And that anticyclone over the U.S. is slowly breaking down here, although the jet stream not expected to become coherent. Anyway, here's your recap. There is the U.S. Doppler radar map depicting vertical motion in the air column from ground-based systems. Here is clouds and fog from space-based systems. And there is water vapor, again, from space-based systems. 6.19 micrometer infrared radiation is the wavelength. And thanks for being on the wavelength of the Smash News Network, least busted name in news. Congratulations on realizing the channel exists. Don't forget to get involved on social media. Press the share button, press comment, etc. We'll see you soon. While I'm gone, may that solar wind be at your back.